Good afternoon, everyone. My name is Karia Monike. I'm working with one Latinga, one Zoo, and Professor Haltan on this project, Special Knowledge Acquisition for the Visually Impaired Users. According to the World Health Organization, there are 285 million visually impaired users in the world. These users have difficulty moving around indoor systems, thereby making going out for them really difficult. So this research project is meant to improve their life, the quality of life for these users and these people, and how to better improve this than having a mobile game. Our objective was to create a mobile game which is going to teach the visually impaired users how to navigate around indoor systems. And my part of the project particularly was to create a convenient and effective user interface for them, because user interface and human-computer interaction is a very vital part of the project, because these people are visually impaired, as you all know, and they need to get effective communication back from their devices. We proposed a pre-journey mobile game for these users through the concept of gamification. The user plays the game, learns the route, and ventures out into these indoor systems. The challenges that were faced along the way included how to have effective human-computer interaction, integration of Android Studio, that's integration of two platforms, Android Studio and Unity, into one, because we had to get the Android Studio part of it and the Unity part of it. And we also had a problem with generating semantics of the 3D map and making our pathfinding algorithm effective, being able to get the required outcome. No doubt there have been some other projects being done on this, but most of them are difficult to scale, expensive, or just plain heavy, and they needed other processes. So our approach was quite different to solving this problem. We had to load a 3D JSON map. A JSON map actually is like a file that has coordinates and vertices of important parts of a map. And through this, the game starts up and the user selects what they want to select, and using haptic inputs, that's touch, and they get back audio feedback. And the game gives them instructions based on what they have said. This is like the process flowchart of the project. The game starts, and there's a 3D map generation that's inputted in. Then the user selects what they want, where they want to start and where they want to end, gameplay, and there's an evaluation stage. Then if the user learns the map, there will be a test here. If yes, the game ends. If no, the user goes back to gameplay process and starts all over again to achieve the goal of teaching them how to learn this map. What's in progress now? Actually, we have like a previous demonstration, a previous prototype that has been worked on over the last semester, but right now we are working on some other design models based on feedback. We have a 3D map preparation. It's more like the map is now being prepared in a different way as opposed to the way it was before. We have database integration, which involves putting the map layout and map information in a database as opposed to putting them in our codes. And we actually communicate with this database with Android Studio with specific queries to be able to get the values and put them in a list. And we have a new selection process, which is incorporated in Android TalkBack. Android TalkBack basically is the accessibility feature of Android. As we all know, these mobile devices of today have accessibility features that are being used by the visually impaired, low vision, or those who have hearing disabilities. So the accessibility feature of Android is TalkBack, and this feature is built in, and this was incorporated because we found out that the previous version had problems incorporated with when it ran on TalkBack, because by default from our tests, the users had TalkBack always turned on. So this process actually eradicates text-to-speech plugin, which we use in a formal procedure, and eradicate some other need to incorporate some projects in it. Now this is like a sample of what actually is going on in Android Studio. This is like the unique new interface with buttons as opposed to the former model. And this is like a sample of the Android Studio project going on. The gameplay process was actually changed also. We changed, we applied the different pathfinding algorithm and interactive walls to give a different audio feedback, but still based on text-to-speech. The new features of this current game, as opposed to the previous one, is it gives the user the nearest location to the starting point. It allows the user to automatically select the closest to them. We use the egocentric form of input, as opposed to the previous one we had. The level of detail also is allowed to be chosen by the user. Simple representation of our gameplay. This is like a map layout with the users at the starting point, and this is the goal here at the end point. So this is like the demo of how it goes. The output there is like audio feedback. So I'm going to play like a short video. That right there is I'm sorry. It's not loud. There is audio right here. So this is like a demo of the game. His eyes are closed because we have to test it as a blind user to see if the information is being passed on. The audio feedback is kind of low because of the laptop. So these are like the previous choice options. This is like a scroll. This is like the way it used to move in the previous layout. The audio is kind of behind the video because of the recording system. This is like a 2 building layout, and so this is like basically like a demo with instructions. The algorithm is actually leading to give back feedback on where to move and where not to. So like that. This actually is oh, it's a building in San Diego. I thought it was a building in City College. So, sorry, that is quite fun. But we applied the gamification process for the concept of pre-journey. The game was developed in Unity 3D, and because of the accessibility need, we had to incorporate Android Studio for the user interface. The final goal is to be able to help the visually impaired users to move around in the systems. In the future, we hope to incorporate a training process in the game to be able to enable them move around, to be able to enable them to learn how to play the game, because we found out from our test that they actually play the game like 2 times before they get used to it. Implement a summary page, because that's one of the needs that they requested for. We are going to use a data structure process for that to be able to get the output. In the meantime, we are going to work on user study on our current app and improve on the app design based on feedback. And we plan to work with different New York and New Jersey transportation hub to improve and to deploy the app, hopefully, to especially places like subway and other busy areas that the blind might have difficulty traversing in. I want to thank LSAMP, Bureau of Mechanics Community College, Dr. Hautam, who is the professor and mentor of this project, Nobu Tewing, undergraduate at City College, Juan Lakinga, who is involved in the algorithm of the pathfinding, Wang Zhu, a student at PMCC, references that was used in the project. Thank you.